Hello, the topic of this class is exploring mass and weight, and the objective is to understand the difference between mass and weight and to state that mass is a measure of the quantity of matter in an object. To begin with, look at these questions. Do you think you can ever lift 200 kilograms? Is it possible to lose weight without diets? So take a moment to think about how you could do this. Are you ready? What are your answers? Okay, now let's remember some basics. What are all physical objects made of? Okay, perhaps you gave different kind of answers, but perhaps we can all agree that all physical things are made of matter, right? And matter has different properties such as volume, odor, color, etc. But the property we are going to pay attention to today is... That's right, mass. So we can say that mass is a property of all physical objects, and we can just define it as how much stuff the object has. So the way we can measure mass with a balance is comparing a known amount of matter to an unknown amount of matter. This is, if you want to know the mass of an object, you need to find an object whose mass you know, and that balances the weight. For example, here in this picture, if you know the mass of the stones on the right, then you can tell that the mass of the left stone is that of the 4 stones on the right. And the unit that we use for mass in the international system is the kilogram. And well, believe it or not, in the imperial system, people use the slug. Okay, so you remember the slug, like the little friend that we have over there? And one slug has a mass of 32 pounds. So if you are 100 pounds, that is like 45 kilograms, then your mass is that of 3 slugs. Okay, so now a different concept that many times is confused with the mass is the weight. But, well, the difference is that the weight is just the force that pulls an object towards Earth. And, as you might have already guessed, this force is due to gravity. And, as you saw in the previous lesson, near the surface of the Earth, it is around 9.81 meters per second square. This means, yes, the weight changes according to the location. The mass doesn't change. It is always the same, since the quantity of stuff in an object doesn't change. For example, in space, you can see astronauts floating, right? So why is that? Is it because their mass is 0, or is it their weight? Exactly, okay, so the mass doesn't change, okay, remember that, because it is a property of the matter. So what changes is the weight because of the location. So the weight is 0 in space. Why is that? So remember that we said weight is due to gravity. Is there gravity in space? Well, yes, okay, but it's almost 0. So we can deduce that in space, W is 0, where W is the weight. There is no gravity, so let's say G is 0. Therefore, when gravity is not 0, okay, gravity is not 0, the weight is something times gravity. Can you guess what is within the parentheses? What is that something? So that something is the mass that we use dm to refer to. Therefore, the weight can be defined as the mass times the gravity. What about the other planets? Do you think gravity is the same as on Earth? So let's play a game, shall we? I'm going to share with you a link to a page where you can enter your own weight or anybody else's and check what that person's weight would be in different planets or moons or stars. Okay, so now if you haven't done the calculation or if you didn't write it down, please pause the video and please do that. Ready? Okay, so now let's check your math. So now you already have like what weight is. So that is a relation between the mass and the gravity. Now, using your math, can you do the opposite? Can you do the invert operation to calculate the gravity? So please pause the video and do the calculation. So finally, do you remember the questions from the beginning? How or where do you think you could lift a 200 kilogram weight? And how or where could you be lighter without diets? Bonus question. When you follow a diet, do you lose weight or mass?